We have reached the end of this series of tutorials, and I hope you have found them useful in understanding the potential of the MTC ChromaWarp panel. To quickly recap, it works using 6 different color controls that allow you to start with an input color and transform it into an output color of your choice. It is very intuitive. Start with a color, either predefined or sampled, and move the radius or sliders to achieve the desired result. Sometimes the result is surprising. In a case like this, for example, simply take the yellow slider and change its hue to neutralize the area of the photo illuminated by the warmest light. This is probably not what you want to do, but it is important to note that the image quality is not affected by such a dramatic maneuver. Things are a little different if we try to do the same thing with the hue saturation adjustment. You have just seen that in MTC ChromaWarp it was sufficient to change the hue of one of the samples. With the Photoshop adjustment, the same operation gives different results. If we select the yellow area and move the hue slider, the colors change cyclically, but in no position do we get close to a result similar to the one we saw. The difference is due to the fact that the MTC ChromaWarp algorithm is completely different from that of Photoshop. Furthermore, in hue saturation, it is not possible to define an output color. We have to use numbers, and this is not easy because the adjustment has a complex effect on the parameters, and the action of a single slider influences more than one color characteristic. Regarding the fact that MTC ChromaWarp works internally in LAB, it is worth remembering that the conversion takes place behind the scenes, without you having to worry about it. Except in one case, when you are working on a set of images encoded in different RGB color spaces. The one we are looking at, for example, is sRGB, as we can see in the lower left corner of the screen. If we go back to the photograph used in the last tutorial, we find that it is Adobe RGB. Can we proceed? Yes, but first we need to update the color space in which MTC ChromaWarp works. We can do this by selecting Update Color Profile from the menu at the top right of the panel. A window appears informing us which color profile is currently being used, and we have the option to update it if it doesn't match that of the image. In this specific case, we are in Adobe RGB, but the panel uses sRGB. After the update, everything realigns. If you need to fix certain colors so that they are not modified, you have 2 options, using anchor points and masks. We have analyzed both methods in previous videos. As we explained, although MTC ChromaWarp is very selective, if 2 colors are extremely similar, it is impossible to separate them. For those with more experience, the limit is dictated by the delta E value, that is, the color distance calculated in LAB. In most cases, however, this will not be a problem. Finally, it is worth emphasizing the great innovation represented by the letter P, or perceived brightness, which is not found in Photoshop. The brightness defined in the HSB and HSL color models is not very relevant from a perceptual point of view, because it doesn't give the right weight to the individual color components of RGB. The use of HSP, on the other hand, is a more correct approach, and avoids the posterization that regularly occurs when applying the hue saturation adjustment in a dramatic way. So, thanks for following me so far. I hope you found these tutorials useful and look forward to seeing you with another set of tutorials in the future. Thank you very much for your attention and bye-bye.